name's Eleanor Saitta. I run a small security consultancy called System Structure Limited. Yes, the acronym is intentional. Anyway, we do fractional CSO services for kind of pre-A to post-C series startups. And I'm here to talk to you today about a couple of different styles of security that I see dev orgs doing. Now, the way I'm presenting these is a little bit of a caricature. I thought we would start with an appropriate quote. So this is an exaggeration, but all of these examples that I'm about to give are real examples that I've seen from real teams doing real things in the world. So let's talk about how you can stop phishing. So there are two approaches to stopping phishing out there. Type 1, kind of what we'll call a type 1 company, is you run phishing tests, right? Let's say we're not getting enough engagement. Let's put up a leaderboard. Let's make it a game, right? So you can tell who in the company is getting caught more often, and they can be shamed, right? And and everybody can compete to this. This is definitely going to drive engagement with our security training. And if you happen to click on one of our phishing tests, then we're going to require mandatory training, right? We're going to steal half an hour out of your day every time you click on one of those links. And the tests are just kind of rolling, ongoing. We do them, once a month, whatever. And inside the security team, we're going to compete to see who can make the most effective phishes that get the most people to click on the link, right? This is how you get the phishing test email that says, hey, here's our new COVID vacation policy. Click here to get your extra week of vacation written in exactly the template that the internal HR emails use. The only difference is that it's coming from an outside source. You can find the tweets that came out of that phishing test. They're not very happy. Because yes, a lot of people were taken in. They thought their company actually cared about them, and it turns out, no, it was just another phishing test. The other option is that you can, instead of doing phishing testing, you can make phishing not matter as much, right? So, okay, credential phishing. Credential phishing is super scary. Let's roll out U2F tokens. Because we know that TOTP isn't great because a smart phisher will also just, after they've taken the password, they'll try it online, then they'll see, oh, there's a TOTP prompt. Okay, I'll send the TOTP prompt to the user. The user, gets out Google Authenticator, types the number in. Great. They've now had the expected login experience, so they're less suspicious. So instead of that, we'll use U2F tokens, where the hardware token says, oh, whoops, nope, that's not the right TLS cert coming from this site. I'm not going to let you log in, right? So now you don't have to have credential phishing problems. We'll eliminate the native Office clients on any desktop machine so that I don't need to worry about a Word document coming and running malware, right? Because you don't have Word running in something where it can run malware, right? So now I've eliminated probably my #1 vector of local exploits. Same thing with Adobe Acrobat, right? And we'll build some out-of-band confirmation loops for like, oh, can you please send a wire transfer to this person? Fine, there's a policy that says we call the exec on the phone. It's annoying sometimes. It wastes 5 minutes of their time, but it means that we now get to, that whole set of social engineering things are out of the way. And then, we'll mention phishing briefly in the annual training, and we'll take action on phishing emails that do come in and get reported, but we're not going to bother doing these phishing simulations trainings that just drive hostility. So working with other teams. So one way of doing it might be that we pass a bunch of policy that we use kind of like maybe the compliance stick, maybe some other stick to get pushed through that put hard checkpoints into everybody's processes, right? Well, okay, you've got code that you want to push to production. Yeah, you're going to have to put it into our security review queue. The current delta on the current time on the queue is about 3 days. We'll get back to you on this commit in 3 days. And also, for instance, we've got restrictions on what functionality you can use in prod. We're calling these guide rails, but we've just made a bunch of features in the cloud environment like, oh, I'm sorry, you just can't turn that on. You're going to have to go talk to somebody to turn that on, and then it's a whole negotiation. Which is fine, but we haven't documented any of this. So you find out about things that don't exist in your prod environment when you push to production. Seen both of those. Alternately, you give devs candy. This is a thing that we did at Etsy. There were lots of healthy snacks in all the buildings, but the security team had candy. So if you wanted candy, you came and talked to the security team. It was literally, it was one of our line item budgets. The team spent like $1,000 a month on candy or something. It's a big company. It adds up. Like, it's not crappy candy. It's like the good chocolate. And everybody on the security team was assigned a couple of teams to go make friends with. Sit in on their, at least their weekly stand-ups. Have, sit in on a team meeting every week on the teams that you're working with, and just like be fun and find out what they're working on. And that means that you hear about their plans early, right? You work with those teams, and each one of those teams has someone who they actually genuinely know, not just sort of like, I've been in meetings with you, but like actually know who they can talk to about what they're doing. Oh, I have this weird question about this API. I've never used it before. How do I do this? This is bugging me. And then everybody gets a good chunk of their time on the security team is having those conversations. So how do you defend a service? Say we've got a new service that we're going to stand up. Great, let's put a WAF in front of it. Now it's safe. And maybe we'll put a firewall appliance in front of it as well. Now it's really safe. Also, well, it has to run on a VM. We can't use a container because we need our endpoint tooling to run on where that code is running. So now we've got endpoint tooling, we've got a firewall appliance, we've got a WAF. That means the service is safe. Or, you have a human test it, you have some robots test it. You instrument it to see what it does, so you can tell if it's acting weird, if it's making calls to places that it shouldn't be, if it's, running syscalls that it's not intended to. It goes without saying that you're running in a container here, so you've got one process that you can instrument, that you can meaningfully manage. You make it immutable, so it doesn't have any writable disk on the host that it's running on. You make it ephemeral, so if it does get compromised, that container only lasts for, I don't know, let's say it's if you've got good fast container roll, maybe it lasts for 15 minutes, and then you just roll, and you're just constantly doing a roll. So great, pop a container. Good luck persisting. You're going to have to use that exploit again and again and again, and generate a ton of log noise that we're then going to notice. Eliminate egress, right? There's no reason if it doesn't need to talk to hosts on the internet that aren't talking to it, it shouldn't be able to talk to the internet, including DNS. Add rate limiting, right? That's what actually defending a service looks like. And yet, I also see type 1 probably equally often. How do you handle compliance, right? Compliance often ends up landing in security's wheelhouse, especially for things like PCI, but honestly, even if you're dealing with like Sarbanes-Oxley, et cetera, often somehow that stuff ends up, if it doesn't fall on compliance, then it kind of heavily shapes how security is also working, and they tend to be pretty involved in it. So type 1, well, you look at the standard, and you treat that as an architecture document that tells you how you're supposed to build your applications. So you design with that standard in mind, not with meeting the standard, but letting the standard actually drive your design process. There's a lot of paperwork involved in a lot of these standards, right? Okay, you're getting a SOC 2 Type 2. You've got all of these audit records of stuff that you need to generate. Well, we're going to need to hire 1 to 15, it depends on how big the team is, people who just do the paperwork, right? They just, they're there when the manual review of roles happens every month, and they check off that each one of these roles has been reviewed in a spreadsheet, and then they send the spreadsheet to the auditor, and like for SOX, you've got all of these manager reviews, et cetera, and we're just going to use a big policy stick to say that, well, you have to do your part, right? If you don't do your part, you'll be fired, and that's the negotiation around how this affects people's workflow. Alternately, figure out what's technically sensible for the spirit of the compliance regulations that you have to follow, right? So PCI has a lot of requirements around segmentation. Okay, so we need to look at how we segment cardholder data from everything else at a bunch of different levels. We're not going to let that drive, like that's a high-level requirement. We're not going to let that drive our architecture, but we need to figure out what the sensible version of that system is based on our architecture. And then we're going to do a ton of automation, right? All of that compliance work is going to be automated. That spreadsheet that says that we've done the review is going to be an artifact of, okay, we've we've run the checker against all of our SaaS tools and our internal systems and our HR database and the list of what privileges people are supposed to have in roles, and then we've manually checked all the exceptions that those are still valid, and the output of that is a spreadsheet, and that goes to the auditors, and there's almost no human involved. And then often this means, okay, so we have an unconventional architecture here. I know a guy in the UK who managed to get away with a completely unsegmented set of PCI VMs because they were running in the same pool as or PCI containers. They were running in the same pool as everything else, but he'd put adequate protections around them, and they were incredibly short-lived. And he could show from code audits, et cetera, that they were in practice segmented despite not running in a separate environment. This takes some work to sell to an auditor. It's a conversation, not a just check all the boxes. Sometimes, depending on the regulation, you're going to have to talk to, you're going to have to pick your auditor a little bit carefully to find someone who is actually technically competent so that they can understand a novel approach to these things. But what you get out of this is an actually secure environment that isn't dictated by regulations, many of which kind of push you towards very 90s era structures, and that, also you haven't alienated your entire developer community, et cetera. Fixing vulnerabilities. So let's say type 1, you're a small team. You have an instance of a vulnerability. You write some code to fix that instance of that vulnerability, and then you repeat. Type 1, big team. Write some code that creates a statistical mitigation, and then roll that out as a framework, right? And when I say a statistical mitigation, let's say for SQL injection, we're going to run all of our input through a regex that strips out semicolons and single ticks and single quotes and double quotes and whatever, right? We're going to strip a few HTML characters. Or ASLR is another great statistical mitigation, right, for C code. We're going to do some address space randomization, and now you're going to have to play a guessing game. And it works until the attackers learn how to get around it. Both of these things are things that attackers have learned to basically get around. Now, there's a longer conversation here. Does that add some friction? Yes, it adds some friction, et cetera. Or you fix the underlying structural problem at the framework level, and then you build testing to confirm that you've covered all of your paths, right? And so this is going to be, for instance, for SQL injection, it's just, do we use any non-parameterized query functions anywhere in the code base? If you use non-parameterized query functions, you get rid of them. Great, now I don't have to think about SQL injection, and that test runs on every commit, so I don't have to worry about somebody introducing it. Great, done. So this is, class fixes versus non-class fixes. Ideally, for the SQL injection example, what you do is you just create a wrapper library around whatever your SQL library is that cuts out all of the functions that you don't want to use. All the non-parameterized query functions just simply aren't available. And then any code that's committed that doesn't include the wrapper function, and assuming you're in, say, a sensible language that lets you shadow other functions, et cetera, any code that isn't calling through the wrapper function just gets rejected at commit. Now I don't even need to test whether or not someone's calling the unparameterized function. I just test that they're only calling the wrapper function. Done. How do you handle mistakes? So let's say you've got a breach, and it turns out that the cause of the breach is that the new junior IT guy changed some firewall rules, and he didn't know what he was doing. So what do? It's a really bad breach. You're in the newspaper. Well, first thing you're going to do is fire the guy, and that's going to be the lead entry in all of your PR that, like, the person responsible for this has been terminated. We regret the error, et cetera. Right? Great. Now you've told people that if they fuck up, the first thing that's going to happen is you're going to tank their career. Guess what they're not going to tell you when they fuck up? You're going to find out about that breach when you actually, when the owning has gotten bad enough that you notice it somewhere else. You're never going to hear from that person that they fucked up because they're afraid of you. Instead, fine, okay, let's sit down with the person, let them know that this was an honest mistake and they're not going to get fired. Ideally, you put that in their employment contract, that we don't fire people for honest mistakes that aren't part of a consistent pattern of underperformance. And then you say, okay, well, accountability here, to be accountable means that you need to give us an account of what happened, right? We're going to ask, so how did you end up making this change? Like, just not as a judging question, but literally how? What was the chain of events? What did you understand about what this change would do, right? What information did you have that led you to do this, right? Is this a thing where we need to provide some training on, like, I don't know, we're talking about S3 buckets, say, right? We need to provide you some training on the S3 ACLs, and we need to make sure that everyone has that, because the S3 ACL language is an abomination that makes people shoot themselves in the head. Or is it that you were under massive time pressure, and this wasn't actually your job at all, but 3 people were out sick, and and you were just trying to do the best that you can because there was an outage, et cetera. Okay, now this says some stuff about staffing, about backup roles, about making sure that we've got the right people in the right places. There's a whole set of big structural problems that come out of that, right? It has nothing to do with this guy who was doing the typing, right? He was the one who made the human error, but it was actually the entire structure around him that caused the fault. So you fix the structure. How do you make decisions? Look at industry best practices and compliance requirements and do what everyone else does, because no one else is getting owned. Buy the things that you have a budget for. Maybe argue for some more budget, just because it's mostly about status. And then anything that you can't buy a solution for, you put in the risk register, and now it's mitigated. Yes, I have actually seen this. All of it. Or you reason about the technical and business and human systems that you're trying to solve from first principles. You make sure that you have teams that can actually reason technically both about the parts of the systems that they do understand and the parts of the systems that they don't understand. You design a system that meets both the business and the security needs, and you implement it collaboratively. Now, I think at this point in this incredibly stereotyped presentation of these 2 types of things, everybody knows which type that they should be on. And obviously, as I said, this is a biased presentation. I haven't seen all of these things in one company. I've seen a few bits and pieces. None of these are specifically a single client, but. So I'm going to give you a couple of very quick tips. If you are just starting out, right, if you have a new startup, here are, I haven't counted, some number of things that you can do to make your life easier. And a lot of these are like IT things, right? Get rid of your Windows fleet. Just recycle them. Switch to Mac, switch to Chromebooks. You're going to make your life way easier. Get rid of Office, even for the finance guys. I promise you, Google Sheets can do everything that Excel thinks it can. If you really have somebody on legal who insists on Word, they can almost certainly do it on Office for the web. Now, great, you don't need to worry about getting owned by Office documents. YubiKeys for everyone. Everyone in the company gets a YubiKey. Buy extras, they'll lose them. It's generally like, I don't know, lifetime of a YubiKey is about 2 years before somebody loses it on average. It's fine. Get everything tied into SSO as soon as you can. If there's stuff that's really expensive because everybody likes to charge extra, maybe wait on that. Get some things to Canaries. This is my other product pitch. They're an amazing, incredibly fast to set up little either Raspberry Pi or appliance that will do nothing but tell you if somebody tries to compromise them. So they will let you know if someone is in your network. They're the cheapest insurance you can get. Back up everything. Make sure that it's actually tested. Track where your data is going. Be careful about where it goes. If you're using Segment, maybe write a wrapper function for Segment so that it doesn't automatically snarf up every single field on every single page, including the internal admin pages that you have it deployed on, and spray it through some set of third parties. Same thing with Google Analytics and a bunch of these other tools. Know where your data is actually going, especially know where your IP is going. Treat code as an expense, not an asset. You spend lines of code to buy features. Code is not an asset. Code is a problem. The more code you can delete and get rid of, the less expense you have, the less debt you have sitting on your balance sheet. When we talk about technical debt, some code is more expensive than other code, but all code is debt. All code is guaranteed to be debt if for no other reason than when you realize that you have to refactor and change the structure of your application, every line of code is potentially a line of code that you have to rewrite. So the less of it there is, the less debt you have. Include maintenance when you're costing your new SaaS tools. They are wildly more expensive than you think they are when you have to actually maintain the ACLs, make sure they're backed up, make sure that the policies, et cetera, are up to date, all of this different stuff. That ends up being incredibly expensive. You know, and a 1,000-person company that's actually managing their SaaS tools well and hasn't been careful about how many they've brought on board, that might be 10 people's job, is just managing those tools. That is expensive. That is very expensive. Anyway, so if you are starting a new startup, here's a list of things that will make your life slightly less painful later on. So I was talking about kind of systems reasoning, and I'm going to dive in a little bit into kind of a very quick intro to systems thinking and principles for building more secure systems. So any system, a service, an application, a whatever, exists to do a thing in the world, right? We don't build software. I mean, even if you do build software as a hobby, you're probably not just writing code for the beauty of the code. If there are any Lisp programmers in the room, I apologize for that insult. But for the rest of us, we are probably writing code because we actually want it to do something in the world, not just in the computer, but like there's some goal that we have of a business process. I don't know, turn a light switch on and off, right? There's something that we want to have happen. To be useful, there are a bunch of emergent properties that they need to have. We'll talk about those on the next slide. Emergent properties are basically whole system properties, right? So security is an emergent property. A system is secure in a specific context for which it is used, right? Is an iPhone secure? I don't know. What are you using it for, right? How are you interacting with it? What are you trying to do? Are you trying to run a nuclear submarine off of it? It's probably not secure. You should not use your iPhone to run your nuclear submarine. So there's a context that matters, and it's the whole thing, right? The thing that we've learned about security vulnerabilities is that they come from complexity, right? If you have one piece of code, you have one bug. If you have two pieces of code, you have three bugs because you have the bug in each piece of code and the bug in the interaction between those two pieces of code. And you get that geometric expansion, and you can only say, is the system secure when you're considering the whole thing. Now, where you draw the boundaries depends on who's using the system, who you care about, et cetera. That's a much longer talk. All of these properties, because they're whole system properties, require unified effort from everyone interacting with the system to deliver. So here are some properties you probably care about. Correctness, right? Does the system actually do the thing that it's supposed to do? Performance, does it do it fast enough at a level of compute spend which I can afford? Efficiency, how much compute spend is there? Reliability, does it always do the right thing? Does it sometimes do the right thing? Observability, can I tell if it's doing the right thing? Can I tell if it's doing the wrong thing? Security, does it do the wrong thing? Resilience, if I do something to this system that relates to any of these properties that takes it out of its intended operating envelope, right? That is not a foreseen failure. Can the team and the system working together, can the whole human and technical team combined maintain a certain amount of functionality, right? Does the system break or does it degrade when I am dealing with some out-of-context problem? Because any real system is eventually going to leave the bounds that you predict for its operation, because no one can afford to write code that handles every possible failure mode. If we mean there's actually every possible failure mode, right? You have to scale up by 7 orders of magnitude, and it's a Tuesday night, and there's always going to be an edge case, and you don't want to, nobody can write code that can scale up by 7 orders of magnitude from the same code base, because even if it's reasonable, it's not affordable, right? So resilience is the property of when that scale-up push happens, how does the team react? How does the overall system react? Do we maintain the other properties that we care about? So, what is security? A secure system is one that enables people to predictably accomplish their goals, right? It's no use if, well, it works on Tuesdays, but it doesn't work on Wednesdays. This is not a secure system. Unless you only need to use it on Tuesdays, and even then it's probably not. It does so in the face of actions from an adversary, right? A chosen set of adversaries. You are probably not building systems that need to stand up to direct, targeted, properly intentional attack by the GRU. If you are, you have a different kind of problem. I don't know why you're in this talk. I'm happy to talk to you afterwards, but that's a different set of problems. So there's going to be adversaries who are in scope. There's adversaries who aren't going to be in scope. Most of the time, we're building systems that are dealing with kind of what I call the passive adversaries, the set of adversaries that are sort of normal and happen to you all the time. I'll talk about that more in a second. Predictably prevents that set of adversaries, there's some words cut off, cool, from accomplishing their goals, right? So let's say there's a great talk a few years ago by a guy from DNS who was looking at why he had scammers in his system trying to steal free domain hosting and track the whole value cycle for what those domains were used for, how they were used, why it made sense. And in fact, sometimes it wasn't even free domain. It was people buying domains legitimately, using their DNS hosting for malicious purposes. And he wanted to understand, like, what's the goal that these people are trying to accomplish? Because I don't want them in my system. So understanding what your adversary's goals is a useful part of that. Alternately, reliability and correctness of outcomes in the presence of an adversary, and closed-loop defense of those outcomes, right? Being able to say that you understand when the outcomes are deviating from their intended path and, observe, orient, decide, act. You've got a closed loop on how you're defending that system over time. And the system is reliably correct for all of the outcomes that matter from a security perspective. So resilience, I talked about this a little bit more. I'll skip over this. But the important thing here is that resilience, as opposed to reliability, is a property of humans. Systems without humans are not resilient. They may be reliable, but they're not resilient, because resilience is about out of context, is about when the system is operating outside of its design parameters. So a lot of what I talk about is how you design for resilient security. And the reason why this is interesting is this is where we talk about how do we work with other teams, right? It's how we talk about that whole gestalt structure of culture, of dev processes, of security processes, and all the technical side of things. So I'm going to stop here. I was talking for a minute about adversaries. And we are in an interesting time, both in Europe and in the US. And the adversary sets that many people are having to deal with are changing, not just because of all the fascism, that's part of it, but also because more and more parts of our lives are going online. You are responsible for the work that you do and the impact that it has on people's lives. This is true for literally everyone, but especially everyone who is developing technical systems that scale, because that's the whole point of programming, is that it allows us to do things at scale. So you are responsible for the impact that that work has on people's lives. So I want to suggest 3 personas. When I talked about adversaries earlier, one of the things that we are often not thinking about is that there are people using our tools who are significantly more exposed than our kind of image of who a user is. And this is true almost regardless of what the piece of software that you're looking at. So let's look at 3 different personas, right? Say one of your users is a domestic violence victim seeking an abortion, right? And this applies in more contexts than you think, right? You are a bank. Well, you have somebody who probably has a partner who's trying to exert financial control over them and who needs to go spend some money in a deniable way, or in an unlinkable way, right? You have any kind of chat service almost anywhere, right? People need to talk about this stuff. You are going to get users in this position. If you have any kids using your systems at all, if you're building systems for kids, some of those kids will be talking about their sexuality, their identity, and will not be out to their parents. And a few of them will probably be in a place where if their parents find out, they'll kill them. You are responsible for what happens. Not completely responsible. There's a lot of different layers. But if you don't think about that, your system will end up causing this outcome in the world. And you should probably think about whether or not you're okay with that, and then think about how to deal with that. Also, union organizers. Great, you build a B2B system that helps teams work together. Great, you've got companies trying to unionize. or employees trying to unionize. I know that in Europe, this is much less of a big deal. However, if you're selling SaaS products, you have Americans using your service. I apologize for what the Americans are going through right now, but kind of from a harm minimization perspective, it's useful for all of us to deal with this question. And a lot of other countries have this problem as well. Anyway, back to talking about some principles. So I've got, I think I've just got time. I'll go quick. I've got 8 principles, 4 which are about technical components and 4 which are about teams that I want to talk through real quick as an example of principles to think with if you're trying to do type 2 style security. So first off, state and logic. A service should either hold state or do computation, not both. If a service does both, its behavior is going to be much more difficult to predict, which means it's going to be much more difficult to understand, does it only do the things that you intend it to do, or does it also do a bunch of other stuff that aren't the intended functions? Immutability and ephemerality, right? Data and configuration and memory are all state, right? If you have data that is holding long-term configuration that is changed on the service, right? If you reconfigure your services instead of redeploying your services, those services are now all holding state, and they are wildly less predictable. How many people here have seen a system get taken down because of a configuration push where not all of your nodes were in this expected state? Yeah, don't do that. You can just not have that problem. Like, you could just not have that outage entirely. We can't do anything about memory, but we can restart stuff quickly, right? Ephemerality, right? If systems don't last very long, then they're back to 0, right? You reset to 0 more quickly. Yeah, maybe there's a memory leak that's going to take your system down after it's been up, after a given container has been running for 72 hours. You should probably fix that, but also if the container never runs for more than half an hour, who cares, right? Minimal and canonical state, right? Every piece of state should exist canonically in exactly one place. If you have multiple canonical sources of truth, now you have a problem of how, okay, well, I changed something over here, and I changed something over here, and I have write conflicts and all of this stuff, right? Design systems so that there's one canonical piece of state, and always push outward from there. You can have caching layers. If you really have to have write back, you can, but you'd better get it right. As few systems as possible should be stores of state, because those are complicated, and you need to protect those in very different ways. If you duplicate state, let's say you have your Terraform, which is sitting in GitHub, and then you have AWS, which is running. Great, that is duplicated state, right? Terraform is canonical, AWS is also canonical, because AWS is what's real, and Terraform is what's canonical. So now you need to validate between these two, right? This is where you get into the kind of tools that let you close that loop, chef inspec, et cetera, that let you say, okay, so is this actual running state the thing that I intended it to be? Unlikability. This is a much more useful way of defining anonymity or privacy, right? A piece of data is unlinkable to another piece of data under these conditions. An IP address is unlinkable to a user's identity if they're using a VPN that is trustworthy and they always use it. This now lets you actually reason about what we say when we mean anonymity, when we mean privacy. So, quickly, some process principles for the human side of the org. For devs, if you can generate, or if you can declare and then generate a thing instead of writing the procedural code, always declare. Because a declarative configuration is easier for a human to understand the intent of, right? The intent is literally what is declared there. And it's easier for the computer to create and compose and validate from that, right? If you need to accept a string and you write a bunch of procedural spaghetti code that is actually defining what string you accept, reversing and understanding which strings you also accept that you didn't intend to accept is an incredibly challenging problem. That's actually probably the #1 cause of security bugs, are broken parsers, along with 6 other things. But so if you instead declare the language or declare the string that you're trying to accept, then you can just look at it and see it. So parser generators are great. Strongly typed languages are great. Type systems are another kind of undeclared undeclared acceptance. State machine generators are great. Design for failure, right? Every system is going to break. Every system is going to be compromised. So design the components and the systems to handle both predictable and unpredictable types of failures. Build the system that you wish you would have in an outage before you have the outage, instead of waiting for the outage and then suffering through all the pain. You could just do it beforehand. Always think about security controls as a whole. Assume that some layers will always fail. Everybody gets owned at some point. Design the system that you'd like to be owned with. Decentralizing decision-making. If you do not let teams work autonomously, decisions are going to happen at the top where people don't actually understand what they can and can't, like what the scope of the decision they're making is, what the implications are. So people need to understand what they have scope for to decide on autonomously, and you should encourage those thick horizontal relationships between teams, like I was talking about with security, outside of formal processes. A lot of these aren't security specific because security is a whole org property. You need to have the whole org reflecting the structure, not just the security team relationship. Coordination and communication are much more important than control. Slack. Resilience requires teams to have downtime. If every single person on your team has been working weekends to try and make your next funding whatever, and then you have an outage and you say, hey, you're going to need to stay in the office, even more, people are just going to leave. And again, I know in Europe we have actual labor laws. It's less common to run into this problem, but you can still be pushing a team to the line, even if everybody is leaving the office on time and taking their vacation and that kind of thing. Especially because if you want to improve any of those emergent properties, performance, et cetera, reliability, that takes slack, right? Because you're getting feature spec after feature spec. If all your teams are doing is implementing features, you can't improve reliability, you can't improve performance, you can't improve security, because the teams need downtime, they need space to think, they need space to actually design appropriately instead of just taking the fastest route for every feature. That means hard caps for feature velocity. If you are a manager, think about how you're going to cap how much work your team does to make sure they have time for all of the other stuff. Also, if you have an on-call rotation, try as an experiment, if you haven't, have people track their sleep. See how often your on-call rotation is woken up, and then figure out if that's sustainable. So anyway, if you have a startup and you're looking to get serious about security, I'm happy to talk more. But any questions?